In 3.2, we're going to specifically talk about triangle congruence. In 3.1, we were talking about polygons. It could be a four-sided shape that was congruent. It could be a five-sided shape that's congruent. But now we're going to talk specifically about triangles being congruent. In section 1, you had to know that all the sides were the same and all the angles were the same in order for them to be congruent. In this section, we're going to learn 5 shortcuts that we can use to prove that two triangles are congruent to each other. But before we get to these 5 shortcuts, this is the main idea of the whole thing, by the way. This will be the main idea. I need to describe to you a few other words that we're going to use throughout these 5 shortcuts. So the first word is this thing called a postulate. When I say the word postulate, it's just a mathematical accepted statement of fact. When we say SSS, it's just an accepted fact that if I have 3 sides that are the same, that the 2 objects are going to be the same when they're triangles. Most people will accept it. Included means between in mathematical sense. So when we talk about an angle being included between 2 sides, it has to be the side and the other side. The angle has to be touching both other sides. When you see the word included, it means between. It also means it could even be describing a side. For example, angle, side, angle is an angle touching a side, touching an angle. The side is in between the 2 angles that we're talking about. I use the word included for these 2 postulates. What we're going to be doing is we're going to be trying to figure out if we can use one of these 5 shortcuts to prove that 2 triangles are congruent. When you look at that worksheet that I passed out to you, worksheet 2, that you all have in front of you, there's a bunch of different triangles that are there. And some of these are congruent. Some of these are not congruent. Some of these we're going to be able to prove are congruent using these 5 things. Some of these we're not going to be able to. So how we're going to do that? We're going to read the triangles, one triangle at a time. We're going to make sure we go in consecutive order. It can never skip a side and an angle, and they must be touching, except 2 angles can't touch. So the sides and angles must be touching. I know that's a weird word for high school students, but remember, we're talking about triangles, and the triangles have sides and angles, and the sides are touching the angles. Don't worry and don't freak out about that stuff, okay? So, how does it work? If you have a side touching a side, touching a side, and another triangle has a side, 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 one congruent marked to another congruent. Doubles means that the double sides are congruent to the other double sides. The triple marks are congruent to the other triple marks. It means they're all congruent to each other. I know these 2 triangles are congruent by the side, side, side postulate. You can abbreviate that to SSS. If you have a side touching an angle touching a side that is congruent to a side touching an angle touching a side, then you can say the 2 things are congruent by the SAS postulate. You can abbreviate that to SAS. And so on. Angle, side, angle. Angle, side, angle. That's how I know these 2 are congruent. Angle, angle, side is the only one that has 2 things that don't touch. The angle can't touch the other angle, but they're next to each other. Angle, angle, then side. Angle, angle, then side. And notice I don't go around this way because I would be skipping this side or this angle. We never skip a side and an angle, which means I can only go around this way when I read the triangle one at a time. The last postulate is this thing called HL, otherwise known as hypotenuse leg. If the hypotenuse, otherwise known as the thing across from the 90-degree angle, is congruent to the other hypotenuse, and a leg of the triangle is congruent to the other leg, they are congruent by HL. Some people get this last one confused with these top four. And they get it confused because some people will look at this and see, let me get the red pin out, a side, and an angle. When you're reading this triangle, some people would read this as a side, touching an angle. There is no postulate. That's why there's this line that's going through there. There is no side angle postulate. It doesn't exist. HL works though, that's across from a hypotenuse, that is a hypotenuse, and a leg that's congruent. So if you see something that it looks like SSA, look to see if it has a right angle. If it does, it might be HL. That's what I say. Let me also just put a little side note here. There is no SSA in here. And an easy way for you high school kids to remember this is you can't say this angle side in school anyways. So just think, oh, we can't have a side angle, or we can't act like a angle side in school. Okay, let's do that. Okay, easy way to remember it. The only other things that we can do when we're doing these problems, we can only add congruent marks because of shared sides. We'll go more into the reflexive property in 3.3a. Because of shared angles, same 3.3a. Vertical angles, we'll get into that today. We know what they are. Parallel line postulates, we talked about that in Unit 1. So let's do a couple of examples together. The rest of these notes are all practice problems. I have 6 of them picked out for you. You have this on worksheet 2 in front of you. The question says, determine if the two triangles are congruent. If yes, state the postulate that makes the triangles congruent. If no, write not enough information. Here's how it works. This is the meat and potatoes, the main course. Okay. If you have a congruent mark, it means you have a side that's congruent to the other side. We're only going to do one triangle at a time. This side is touching the double congruent mark, which is another side that's congruent to this other one. I'm going to cover this up one triangle at a time. Do I have any angles that are the same in both that are, let's say, shared? Do they share any angles? My answer is no, they do not share any angles. Are there any vertical angles? No vertical angles. So what we have is a side and a side, but we do not have a side angle side. We don't have side. We don't have angle side angle, and we cannot assume anything in geometry. Do not assume. So what we would do for this case, determine if the two triangles are congruent, we're going to say no. There is not enough information. If you want to write it all out, you can, or you can just write NEI. If you write NEI, I will know that that stands for not enough information. How come? Because there is no side. I mean side. There is a side. It can only be these 5 shortcuts. Let's look at number 4. We have 2 triangles. I have a single side that matches up with this other single side. I have a right angle that is the same as this other right angle. And I want to know, okay, so I can only do one triangle at a time, so I'm doing this top triangle and I'm not doing the other one. I'm just checking. I have a side and angle. Are there any shared sides? Is this side the same in the top triangle and in the bottom triangle? If there is a shared side, we can add congruent marks only if it shares a side. This one does. This side is the same length in both triangles by the reflexive property. So when I see this, I see an angle touching a side, or a side touching an angle. And I told you that SSA doesn't exist. There is one that looks like SSA. Is this a hypotenuse and a leg that's the same as the other one? If so, we can write yes by HL. HL lets us know that those two things are congruent to each other. It's a hypotenuse and a leg. Pretty simple. You're looking at which of the 5 shortcuts you could use. If you can't, you say not enough information. Let's look at number 5. Number 5 gets a little more complicated. Looking at one triangle at a time. I have a side that's the same as the other side. I have a double that's the same as the other double. So looking at one, I can see that I have a side and a side. Now let's ask, are there any shared angles? Are there any shared sides? Are there any vertical angles? I see a pair of vertical angles. This angle here is the exact same as this angle here because it's made up of 2 intersecting lines. And we talked about that in Unit 1. They're exactly the same as each other. So I can say, beyond a shadow of a doubt, that this angle is the same as that angle over there. So if I'm looking at this triangle, I have side, side, angle, or angle, side, side. Does that postulate exist? Is there a right angle in this problem? So our answer is there's not enough information because side-side angle doesn't exist. Number 10 is where it gets harder. And number 10, it gets harder because of these parallel lines. You have 2 marks that talk about being parallel to each other. We have a side that matches this side. We have a parallel that's parallel to this. We have an angle that matches this angle down here. We do not have vertical angles. This is not a vertical angle with that. It doesn't work. They're not the same. But what I do have, since this is parallel to this, what we have are something called corresponding angles. When we learned corresponding angles way back in Unit 1, I'm just going to draw a quick picture for you. The corresponding angles were the ones I told you that looked like an F. They're right in the corners of the F. Corresponding. Same side, skip a space. Here's your F. This angle here is corresponding. Here's your parallel line. Here's your transversal. Here's your other parallel line. It's the same as this double right there. You can only add them in if you know that they're going to be congruent to each other by those parallel line postulates. We wrote them down in our notes. You can then use alternate interior. You can use corresponding. These ones I'm using corresponding angles. And that adds us an extra angle. An angle that's touching a side that's included with the other angle. Angle, side, angle. Is there enough information? Yes, by angle, side, angle. And the problems that you have on that first worksheet, you're going to have to make decisions based off of those 5 postulates. I'm hoping I've shown you how to add things and what you can and what you can't do. Let's turn that worksheet over, and I have 2 more examples for you. 16 and 28. I'm going to go to 16 first because there was no picture on 16. Suppose all this is GHI congruent to JKL. Explain your reasoning. What I'm going to recommend that you do is I'm going to recommend that you actually draw a triangle and label it GHI. And it asks, is GHI congruent to JKL? So draw another one. JKL. It says, suppose GH, segment or side GH, is congruent to segment JK. Here's segment GH. Suppose this side is congruent to this side. You can add your congruency marks to your picture. We've just done that first statement. It also says that HI is congruent to KL. Don't use a single this time because it's different. We don't ever use the same. Because it may be different, we put a double and a double. HI congruent to KL. The last thing that we have 2 angles that are also congruent, angle I and angle L. I'm going to use an arc for the angles. And I put an arc for L as well. Now if I were writing this down, this is a side touching a side touching an angle. Are these 2 triangles congruent? Explain your reasoning. Can we say, does this match using one of the 5 postulates that we wrote down in our notes? Those of you who said no, I agree with you. Is there a side-side angle? No. There's one that looks like it. It's called HL, but this one doesn't have a right angle. I'm going to put not enough information, or to be more specific, SSA does not exist. The last few problems that you may have to do will deal with, do you understand that a single arc means it's the same as the other single arc? This is 28. And the double arc means it's the same as the other double arc. And if you're trying to figure out what X is or what Y is, you can use previous information that we've already learned, like the triangle sum theorem, which says this plus this should all add up to how much? If you remember, say it out loud. 180. 60 degrees plus 70 degrees plus 2x degrees should equal 180 degrees. Some of you can do that in your head. I can't. I have to work out each piece. I'll subtract 130 from both sides. 2x equals 50. Divide by 2. And I'm getting that x, the value of x is 25. We'll stop your notes right there.